Okay, guys, so this is exactly like the videos that I did earlier. There's nothing new on any of this. You should know how to do this kind of stuff. Okay, if you do distributed property, I did the box method and the regular distributed property like you're used to doing. And so I don't know what the confusion really was. Okay, but I want to do these. A is 3a times 4 plus a. If I distribute that, that is 3 times 4 is 12a. The a goes with it as well. 3a times a is positive 3a squared. So you may have to write that as 3a squared plus 12a because that is the standard form. Okay, a highest degree 2. Remember, this is just a 1. Remember, you can just put a 1 right here. You can also put a 1 in front of the a. It's the same thing. It means 1a to the first. Okay. B, x times x plus 2 plus 1. What's x times x? Well, we're multiplying, so we add the x on it. There's 2. X times 2 is plus 2x, and then plus 1. That's 2 times x right here. We can't do anything with it. We'll just leave it as 2 times x. And that is your answer. 3, or C, I guess. It says 1/3 12z plus 18z squared. Well, what's the same thing that we did this all last year. We said you can either do divide by 3 or multiply by 1/3. So what's 1/3 of 12? That's 4, and the z stays with it. What's 1/3 of 18? 6z squared. And if you wrote that in standard form, you'd have to write 6z squared first plus 4z. Okay. All right. I'm going to erase those now. Oh, I said I was going to erase them. All right. Now then, D is 4x cubed minus 10. That's going to be, when I distribute that, that's going to be 4x, and I got 4 x's now. X times x to the third, we add them, and we get x to the fourth. 4x times a negative 10 is a negative 40x. You got to do it all over here. Now, I'm going to look and see how they want you to leave that. Yeah, that's fine. Just leave it like that. That's okay. Because it wants it to be the sum of monomials. Yeah. So there's 2 monomials here. That's what we want. Now, let's see here. X minus 4. These are going to be the ones that are going to be much more common in the next couple of years. You're going to see factors like this. This is 2 factors multiplied together, and you're going to have a trinomial that comes out of these. So this is full. First outer, inner, last. First is going to be x squared. The outer is going to be plus 5x. The inner is going to be minus 4x. And then the last is going to be, oh, that's not the last. Sorry, forget that line. That's the outers. The last is negative 4 times 5. And so the reason why we do full, your outer and your inner here are going to combine. So that's going to be x squared. We have x's here plus x minus 20. 2z minus 1. And this is the same thing. Two binomials. We're going to do the first. That's going to be 6z to the third, because we add our exponent. Outer is plus 2z. Inner is going to be a minus 3z squared. And then the last, that's not the last. Stop doing that, Mr. Anderson. Okay. The last is going to be a -1. Now, I told you earlier that these are going to combine. Well, they can't here because they were not in the beginning the same degree. So we're just going to leave that as 6z cubed minus 3z squared plus 2z minus 1. We'll just swap these and put it in standard form. Okay. All right, got to erase some. Erase all of those. All right. Now then, we have, these are my favorite. You need to recognize these right off the bat because we're working on these in Algebra 2 right now. These are called conjugates because it's the same terms, 10W, 10W, 1, and 1. The only difference is you have a plus and a minus. The cool thing about these plus and minus are they're going to cancel out those middle terms, okay? Let me erase some of this so we can actually see what we're doing. That middle term is going to cancel now. What's 10W times 10W? What's 10 times 10? 100 W squared, because W times W is squared. Now, if we do the outer, that's just going to be plus 10W. If we do the inner, that's going to be minus 10W. If we do the last, that's minus 1. Well, what's 10W minus 10W? 0. Those cancel and just leave you with 10W squared minus 1. And this is what we call the difference of two squares, because 1 times 1 is 1, right? So that's a square. Okay, the next one we'll do is negative 5W minus 3W squared. Now, I don't like having the W squared on this side. Okay, that's not common. That's just a weird way of doing it, but it works the same way. You're still going to do it times both terms. Okay, so W squared times negative 5W would be negative 5W cubed, and negative 3 times W squared is going to be negative 3W squared. All right, let me go ahead and erase some of this. And I know you are sitting there going, oh, this makes so much more sense, Mr. Anderson just doing it. But if you're not copying this down and not understanding, if I were you, I would stop right now if you've not finished your homework and try and do the rest of my homework by myself. Okay, 16 f to the 100 times 1/2 f to the 200 power plus 0.125 f. Now y'all look just freaked out. Michael's done crying over this. But 16 times 1/2 is 8. S, what's 100 plus 200, because when we multiply, we add, so that would be 300. Now the next term, what is 16 times 0.125? 16 times 0.125 is 2S 101. Because remember, there's a 1 here, and we still have to add them. And there's our answer. That's just simply doing distributive property. Not doing anything fancy. I'm doing the same thing over and over and over and over again. 2q plus 1 times 2q squared plus 1. All right. First, pull it. First, it'll be 4q to the third. Outer would be plus 2q. Inner is going to be plus 2q squared. The last is going to be plus 1. So to write that in standard form, it would be 4q cubed plus 2q squared plus 2q plus 1. All right, now we're going to get to triple or trinomials here. But guess what? We're not going to do anything different. We're still going to multiply everything together. So x squared minus x minus x plus 1 times x minus 1. Okay. So now then, whenever you have more than a binomial, I would just go ahead and go x squared times x is x cubed. X squared times -1 is negative x squared, and then cross it out. So now you've multiplied it by the 2 terms. Now let's do this one. Negative x times x is going to be negative x squared. Negative x times -1 is going to be plus 1. Get rid of it. And then 1 times that's just going to be plus x minus 1, right? And now we're done. And well, we're done with the multiplying. Now we have to combine our terms. I have 2 like terms here. So it's going to be x cubed minus 2x squared. We've just got a term here of x, so plus x. And then these are going to cancel. Plus 1 minus 1 cancels. Okay. I'll make sure I got that right. Uh-oh. Why do they have? I missed something. Let's go back here. Hopefully you caught it somewhere along the way. Should be right in here somewhere. Okay. X squared plus x. Okay. So now that one's done. And this will be plus x minus 1. Yep. Okay. Now I have x cubed minus 2x squared plus 2x minus 1. Now that's right. Glad I checked that. Sorry about that. All right, well, let's go ahead and erase that. Please take up a little bit more room. And now I'm on, or JKL, 3x z times 9xy plus z minus, this is going to take a while, x plus y minus z. And that's the reason why I put my line through my z to make sure it's not a 2. Okay. Now let's just start over here. 3 times 9 is 27. X, I got 2 x's, I've got 1 y, and I've got 1 z. Now let's do this one. Plus 3x, and I got 2 z's here. All right, now I'm going to distribute a negative 2yz to all of these. That's going to be a negative 2. I've got my x here, x, y, and z. And I've got a negative 2y squared z. I'm just going to come down here and say negative 2y. Oh, negative 2 times a negative z is going to be a positive 2yz squared. Okay, now that I've distributed that z everywhere, it's all done. All that is done. Now I'm just going to combine like terms. So do I have an x squared yz? I do not. Do I have an xz squared anywhere else? I do not. Do I have a minus 2xyz? Nope. So I don't have any like terms. That's just it right there. That would be the answer. Okay. What's next? See if I can do this. Maybe we can do it right here. M is t minus 1 times t plus 1 times t squared plus 1. All right. So first thing I'm going to do, I'm just going to work with these right here. And I know those are conjugates. Okay. I've already told y'all that. You need to get to where you can recognize those. Okay. And so this is going to be first, this is going to be t squared. And now I know all I have to do is this, because these are the middle are going to cancel out, but I'm going to go ahead and do this. The outer is going to be plus t, the inner is minus t, and then we have minus 1. Look, those cancel. Okay, so that leaves us with t squared minus 1 times t squared plus 1. And guess what? We have conjugates again. Okay, same term, t squared and 1 in both of the binomials. So now all I have to do is the first and the last, because the middle one's going to cancel. That's going to leave us with t to the 4th minus 1. Because if you do the outer and the inner, those will cancel. We love conjugates. Those are quicker. All right, guys. Yeah, like I said, if you are just copying these down as I'm doing them, you need to be stopping, working them out. If you get the right answer, keep going. All right. I'm actually going, I'm just going to skip down to Q, because the rest of them you should be able to do. Just do this times this, 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 and then come over here and go this. Basically write it all down again, because 1 times all that, this is going to be that again, and then combine like terms. Okay, that should be easy. All right. So let's go down here to Q, x plus y divided by 3. Now, that looks really hard, but it's the same thing. here's what you have to do. You have to divide each term by 3. So what that's going to end up being is equal to x over 3 plus y over 3, or if we don't want to write it as divided by 3, we do the multiplicative inverse, which is 1/3 x plus 1/3 y. And that is your answer. Just divide by each term, break it apart. Now let's do the next one. We'll do R20 f to the 10th minus 10 f to the 5th. All that divided by 5. Now, just like if that was a multiplied by 5, we would do that by each term. But it's a divided by 5, so we're going to divide by each term. So what is 20 divided by 5? 4. Oh, that's an F, not a T. 4 F to the 10th minus 10 divided by 5 is 2 F to the 5th. And that is it. Can't do anything with those F's because the 5 doesn't have an F. Okay. T, I'm pretty sure that T there, hopefully on your homework, that SD should not be there. Hopefully on the problem that you're working at, it's not on there. Okay, guys, I don't see anything that should be tricky. So we'll look at this one. You got to do multiplication first. You have to do your distributive property first. Do your distributive property here, and then combine like terms. Same thing for T. You've got to do this first. You got to multiply each term by every, you got to do distributive property first, and then you divide those by 17. Okay. And then let's see here. Oh, let's do this one. We'll do U together. Okay. 2x divided by 9. Because we're going to go left to right. I think that's all we can do. Okay. That'll be 2x over 9 plus 5x over 2. And then all of that is divided by a negative 2. Wow. Well, I don't like that. So to combine these top ones, you have to have a common denominator. Okay, you can't just, because these are both x terms, so you got to have a common denominator to combine them. So what's that going to be? 18. 18 would be the common denominator. 9 times 2 is 18. 2 times 2x is 4x. 2 times 9 is 18. 9 times 5 is 45x. And all that's over 2 still. So let's combine them. That would be 49, not 59. 49x over 18 divided by a negative 2. Now, Remember, we can divide by a -2 or multiply by a 1/2, or the better thing to do is to rewrite that, I think, for y'all, is to didn't want to erase that 8, but that's okay. So that's divided by a -2. Well, how do you divide fractions? Remember, just put that over 1. Keep, change, flip, right? So let's change that to a multiplication. Okay. And let's flip it. So it'll be 1/2. A -1/2. And when you multiply straight across. So it's going to be 49x over 36. And that's going to be -49x over 36. Following the orders of operation every time. And just do it. Okay. And let's see here. V is just going to be multiplying them all out. Okay. Multiply it all out. And we're multiplying by exponents. We're adding the exponents. And then we're combining like terms. We don't do anything to the exponents. All right. Let me, I'm going to go ahead and close this video. And then I'll send you another one with the next 2 sections done, maybe. Actually, there's no need in this. This is just, they're all squared. So what you're going to do is say A plus B times A plus B. Okay. And that's going to be A squared plus AB plus AB plus B squared. So that's A squared plus 2 ABs plus B squared. Okay, and that's what you're going to do on all of them. Now, if it's to the third, like I is here, P minus 1, that's going to be 3 times. So you're going to do the first one. Okay, P squared. Okay, minus P plus 1. So you have P squared minus 2P plus 1 times P minus 1. And now just do it again. Everything by each other. P squared minus P, negative 2P squared plus 2P plus P minus 1. Combine like terms. So that's going to be negative P squared. All the P's will be 2P plus P, 3P, minus P is plus 2P, and then minus 1. It would have been if I would have done it correctly. I did not do that correctly because I did not, and I knew that because I already had a P squared here. This should have been a P squared. I should have brought that down. So now then that's P cubed when I do that minus P squared minus 2P squared plus 2P and then plus P minus 1. So P cubed. All right, and then our negative P, that's negative 3P squared plus 3P minus 1 when I combine all of those terms. It's just taking your time and doing it correctly. All right, let me see what the next page is. The only one that may cause you trouble is this one, but all that should be easy for you to do. It's the same thing we're doing. There's no need me having to keep doing these over and over and over. It's that same thing. If you have questions about them, you can ask tomorrow during class.